Hello and welcome to SGN Tech Forum. Previously on our channel, you have seen a lot of talk about DNS, how DNS works, what is the importance of DNS, and DNS security. But what we haven't done so far is having a packet walk using Wireshark or DNS as a protocol. And we love doing packet walk on SGN Tech Forum so that you have a thorough understanding of the protocol and the foundation, right? So let's do that in today's video. DNS is a globally distributed, scalable, hierarchical in dynamic database. So it's definitely very scalable, hierarchical. That means entire internet is supported by DNS, and if DNS is not available for some reason, many of the user may not be able to connect to the resources. However, no single DNS server on the internet contains the entire database. Authority over the different parts of the DNS database is delegated to different DNS server on the internet. Here's the link to the previous playlist. You can go and watch the video. I highly recommend you to watch DNS 101, which talk about DNS as a protocol in very much detail. It talk about all the resource records type, zone records type, and how actual DNS query response happens. But for this video, what is our scope? The scope is to have a packet walk for DNS request. So the setup looks like this. We have a home PC, and this PC has a DNS server configured. So I'm getting my DNS information on this PC using DHCP, and the DNS server is sitting on-prem. So I have my own DNS server, and this DNS server, obviously it has to feed from upstream DNS server. So here I have configured Cloudflare as DNS server for my DNS server, and then obviously it goes to Cloudflare. From there it can traverse further based on how the Cloudflare database looks like at the moment. So you may ask for something which is not cached here, and then the DNS server will reach out to the top level domain and get the address and try to do recursive query. So this is our setup. As you can see, my PC is going to send a DNS request to on-prem server. On-prem server will in turn relay this to the upstream DNS server. Upstream DNS server may relay it further. However, when we get the response will be back to return to on-prem DNS server, and then on-prem DNS server will forward this back to my PC, and from there on I know what is the IP address for the website or hostname I'm looking for, and I can start the TCP connection. What I want you to understand from this entire process is the role what we assume during DNS query. So here are the 3 bullet points. Please pay attention here. If the DNS server is configured as authoritative within the process and receive a DNS query about a domain for which it is authoritative. So who can be authoritative DNS? Like a business, say for Cisco.com, they may have their own name server, NS1, NS2, NS3, and so on for others like AOL or Yahoo. Right. So you may have authoritative DNS server, and if a query reaches to that, it will return a response by consulting the record stored in its configuration and will mark this answer as authoritative answer in answer section. And you will see all this breakdown of sections when we go to Wireshark. However, if query reaches to authoritative DNS server and say for example it is a subdomain, say garbage.aol.com, so obviously that is not available. If it lacks this information, it will respond with a message called NX domain, non-existent domain, or maybe this is some department which was in production earlier but now it's not in production anymore. So you may see that subdomain sometimes returns NX domain, and this is done by authoritative name server. What is the second role? If the DNS server is authoritative and is not configured as recursive, which is pretty much a case, and it receive a query about a domain for which it is not authoritative, it will respond with a message containing records in authority an additional section informing the resolver that it does not provide recursion and where it should direct its query so as to obtain authoritative information on domain requested. This is known as referral response. So this is pretty implicit, right? If you are queried for something for which you are not authoritative and at the same time you don't have privilege to do a recursive query, then what you can do best? You can just return the information who should the original query go to in additional section, and that becomes referral response. You will see many a time, especially the top level domain server or root domain server, they are not considered as recursive, because if they start doing recursion, it will be too much work for them. So they are never recursive, and hence they only respond you back with where you can go to get the information. Like if you're asking for some .com or .org, it can point you to the designated or authoritative name server for that domain, and that response is called referral response. Now, coming back to the third point, if the DNS server is not authoritative but is configured to be recursive, and this is the most common scenario. Most of our upstream DNS server, say Google, Cloudflare, they are most of the time the query reaches to them. They are not authoritative for those domain, but they are configured to be recursive. And when it receives a query, it will initiate iterative query, recursion query to find authoritative server for that domain. So this uh, recursive resolver is doing the heavy lifting here for us, right? We know we want to resolve one query, we send it to the upstream who's recursive, and recursive one is going to talk to all TLDs and then the authoritative name server and maybe additional servers. So it is doing the heavy lifting for us, and once it has the answer, it returns the record to the client who's resolver, indicating that it is a non-authoritative answer. So it clearly tells you that this is not, I'm not authoritative, this is a non-authoritative answer, but I resolved it for you. And at the same time, we try to cache this information so that all the uh, hard work doesn't go in vain, right? So next time someone asks for the same information, instead of doing that heavy lifting, it can just look at it. It's a cache info and return. So that if I ask about the same resource, once again, the time that record is marked with expiry, obviously the cache information has to expire in some time. It will reply with the consulting cache. So that faster the query response. So this is very important. You need to understand the roles, authoritative, recursive, and who play what kind of role. Like TLDs, they are always a referral response. They give you referral response. Authoritative, obviously, they are designated, or they have the authority over the domain because it's owned by that entity or the business. And then we have recursion resolvers like Cloudflare, Google, and many more, right? Which resolve the query for us going to different hierarchy of the tree. We will come back to this picture once we go look at the Wireshark. So this is the Wireshark capture where I'm filtering packet with UDP port 53. That is the port used by DNS protocol. And within this, I know at 360, sequence number 360, I made a query, and as soon as I select this, something happens. See, if I select this Wireshark is telling me with arrows, it tried to tell me something here. So it's trying to tell me the query request and response, where it started, where it's ending. So we should focus on 360, 61, 62, and 63. 135, this is my PC, okay? This is 135. This is a Raspberry Pi. It is asking for Amazon.com. And as you can see on the higher level, it's nothing. It's just Ethernet packet, IP packet with source and destination. And then on the layer 4, we have the UDP Source port is random, but the destination port is 53. So my PC is sending a query to my on-prem DNS server on designated port 53. What's inside this query? We have transaction ID which ends in 4E. Then we have some flags here. Flags, as you can see, response, it is set to 0. That means this message is not response. This message is query. This is a standard query. Truncated, not truncated, do not query recursively is set to 1. To query recursively set to 1. That means I'm asking that you resolve it for me to my upstream DNS server. The zbit is always reserved and some other things are fine. Question. This is what is the question? Question here. I have one question. Amazon.com. Who's that? And you can explain that what is your question in queries section. I'm asking for Amazon.com, which is a type A. That means IPv4 type of address. Other classification you can see. So that's where the query started. What happened afterward? As this query was received by on-prem server, which is 192.168.1.111, obviously it doesn't have that information. So what it did, it has initiated another query. Because this is a recursive resolver, it has initiated another query, pretty much same thing as you can see, sending query on port 53, but this time it goes to Cloudflare, which is configured as upstream DNS server. Again, we have a new transaction ID. The earlier transaction ID was ending in 4E, but since this is a new query, there is a new transaction ID. Same kind of fields. As you can see, this message is query, and we do require recursion. And then we have the question, which is who is Amazon.com for IPv4. All right. So what happened? We have two queries outstanding. Now we are getting response. We are getting response from Cloudflare to on-prem Raspberry Pi. So let's look at the transaction ID 6B33. 6B33. So query from on-prem to Cloudflare was 6B33, and that's why the response also matches. Transaction ID, that's how DNS server makes sure which query I'm responding to. So your transaction ID will match. Flags, you can see there is no error. That means we were managed to get the query resolved properly. And this message is a response. Authoritative server. Server is not authority for the domain. Obviously, we know that Cloudflare cannot be authoritative for Amazon. That's what it has been said here. The rest of the fields are pretty much same. We have the query, question, and what you should look at is first answer RR, recursion resolver. How we may get more than one IP address for one particular host name, right? And that's what it says here, that we are getting 3 responses back. As you can see, their IP addresses ends in 85, 248, and 103. You can expand them, time to live. So this much time, it will be, this information will be cached. 6 minute, 6 minute, and 6 minute. Okay. So now my on-prem DNS server has got the response, but eventually I wanted my PC to get the response, right? So now on-prem server is providing me the same information in separate response. And how do I know if it is a separate response? Look at the transaction ID. Here you can see we have the transaction ID which ends in 4E. And if you go back to packet 360, you have a query with 4E. And in 363, we have a response which ends in 4E. So these are the identical transaction query response pair. Here same thing, as you can see, this message is a response. This my upstream is not an authoritative server, and then I received 3 resource records, and these are the 3 resource record, which is pretty much same what we received from Cloudflare. Right. So this is how it basically DNS server can do a request and response and translate an host name to an IP address. Let's go back to the final one. Here, this diagram taken from the website UnixWiz. As you can see, this is the packet structure, what you just saw in Wireshark. So we have the IP layer, then we have the UDP layer, where UDP is, since this is a response, so that's why the source port is 53. And then we have these flags, QR, that means if the flag is set to 1, this is response. If AA, authoritative flag, is set to 1, then this is authoritative. But as you have seen in our Wireshark capture, we had this bit as 0 because never the response was from authoritative. However, recursion was set to 1 because we wanted recursion. Then we have the question count. You may have more than one question count, sometimes subdomains. So that's why the question count was equal to 1. Answer count is also equal to 1. And this is the actual question. This is the actual answer. However, you may have additional records, and here the additional records pointing, sometimes they point to name server, etc. as additional information about your website. One last thing I would like to show you how you can use your CLI. So there are two type of commands available in CLI. One is NS lookup, which is deprecated but still very much available and in use. So you can use NS lookup, and as you can see, it give me the information about where is cisco.com, and it is doing both the query for IPv4 and IPv6. That's why we have it has returned two IP addresses, one for IPv4, one for IPv6. And what was the server used to resolve this? That was my on-prem server. You can also use DIG, which is domain information gopher. This is very versatile. You can have multiple flags with this, and I recommend you using DIG. As you see, I did the same thing, DIG, and it was quite verbose. We have got a lot of information like what is my flag, this is the query, we have received one answer, and so on, the answer section. And again, it tell you what is the server. Right. So this is the IP address of the web server. If you want to consult or want to know who's the authoritative server for this website, what you can do dig and query the root servers, one of the root servers, and there are multiple root servers from A to G. So let's find one of the similar query. So what I'm doing here, I'm doing again dig utility and querying at the rate. I'm asking go to this root server gtld, that is top level domain, a server.net, and ask who is the name server for this website. And as I hit this, as you can see, earlier it was returning me what is the IP address for the website, but now if you do dig at, it is going to return who are the authoritative server. So we have NS1 to NS5 for AOL.com, and these are name server IP addresses. Sometimes this comes handy to know who's the name server and what is the IP address for that. But most of the time, what you're interested in is resolving the IP address for a web server. All right, I think this is all I wanted to show you. I hope you found this video interesting. Please do like, subscribe, share, and spread a word. Thank you. I'll see you in the next video.